In the last lesson, we saw that the graph of sine looks something like that, and the graph of cosine looks something like that. In this lesson, we're going to see the effect of doing a transformation on the graph and how that transformation, whether it's a shift, horizontal shift or vertical shift, or whether it's some kind of reflection, or whether it's a dilation or it's called vertical stretch or horizontal compression, how that affects the equation and how the equation affects the graph. So let's see how some of these transformations work. One thing that you can do is you can add or subtract some number. So what that's going to do is for every point, the y-coordinate is going to go up, in this case, by 2. So instead of going through, here are 1, 2, 3, 4, here's like the 5 main points, 0, 0, 91, 180, 0, 270, negative 1, and 360, 0. This plus 2, when you put 0 in, it's now going to be up here at 2. And at 360, it's also going to be 2. And at 180, it's also going to be 2. So what happens is that sometimes we call this line here that goes through the middle of the sine curve, the just midline, it's going to go up by 2. And that's what that plus 2 accomplishes. The entire curve shifts, every point shifts up by 2. And we end up with something like this. And if it was sine x minus 2, everything, the whole midline would move down by 2, and everything would go down by 2 along with it, so the peak would no longer be at 91, but it would be at 90, negative 1, and we'd have 270, negative 3, and 180, negative 2. If there's a coefficient in front of the whole equation, then the y-coordinate gets doubled. Well, that doesn't affect the midline, because if you double 0, you still get 0. So these 3 points are still in the same spot. But what does change is, instead of having 91, we're going to have 92, and 270, negative 2. And we call this number the amplitude. We can combine the two transformations. If I stick like a plus 1 here, that's going to shift it upward, and it's going to do that vertical stretch. So these 3 0 points end up on the line y equals 1. But the 2 means I go 2 above the midline to get to the high point, and 2 below the midline to get to the low point. So we have 2 transformations. This one's a vertical. This amplitude change is called vertical stretch, and this plus 1 is actually a vertical translation. Now, if I have the 45 is being added to the x, this can be a little bit confusing. The idea is, if I put 0 in for x, 45 gets added to it, so what I graph is actually sine 45. If I put negative 45 in for x, negative 45 plus 45 is 0. So like in some ways, like the starting point ends up over here, because you have to put negative 45 to get sine 0, and 315 would turn into 360 and 135. And what ends up happening is that having a number here doesn't affect the middle line, it doesn't affect the amplitude, but it causes a horizontal shift, in this case 45 degrees to the left. If this was a minus sign, it would be to the right. if you have a number like this, like a coefficient of the x, what this causes to happen is that, like, you put 0 in, it's still sine 0. But over here, I had to put 90 to get to the high points of 1. Here, I just need to put 45 in to get to 1, because 45 times 2 is 90. So I end up like that. And when I put 90 into the second, this one, it does what used to happen when you put in 180 there. And what ends up happening is that everything gets compressed, and when I put 180 in for x, it does what would happen at 360. So we get what's called a horizontal compression. This number is known as the frequency. And if you divide 360 by that number, you get what's called the period. So this has a period of 180 because that's how long it takes to go through one full cycle. Period is equal to 1 over frequency. It's also true that frequency, is equal to 360 over frequency, or 360 over the period. If you have a negative in front of the whole thing, well, that doesn't change the zeros at all, but it does flip the entire curve upside down. So now it kind of starts at 0 on the midline, goes down, then all the way up. Now we can start to combine these transformations. Here's something that has all 5 things going on at once, and I'm going to give you a nice order to do these in. The first thing I would look at is the horizontal shifts, because that tells you where the midline is, so it's over here at 2. Oh, missing from here is the word sine. Now, our curve is going to sort of go around this, somehow. But how exactly? Well, the next thing I would consider is this number, that 3. Because that 3 is the amplitude, so that means I'm going sort of 3. The curve is going to go 3 above and 3 below, so I'm going to draw these 2 guidelines. 3 above and 3 below where the midline is. Now a sine curve starts on the midline, so the next thing I'm going to look at is this right here. Minus 30 means if you put 30 in, it does what 0 used to do. So my starting point is going to be over here at, I'll just write in 30, comma 2. Next, I'm going to consider this 2. This 2 tells me that one period is 360 over 2, which is 180. So if this here, 30 comma 2, is the starting point, the ending point is going to be 180 past that, which is going to be 210 comma 2. Now for a sine curve, you can go sort of, if it starts on the midline, ends in the midline, it's also goes through the midline in the halfway between those 2 points. I'll take the average. 210 plus 30 is 240 divided by 2 is 120. And now there's just one last decision. Oh, now finally I'm going to look at this minus. That minus means that it goes to its minimum point first before it gets to its maximum. So halfway between these 2 points, I'm going to put a minimum on that blue line, and halfway between these, I'll put a maximum. And I connect the 4 dots to get my nice picture of one cycle here. If you like formulas, you start with D, that tells you where the midline is. C tells you where to shift to put the first point on the midline. A tells you where to put the sort of high and low guidelines. B tells you, in a sense, where to put the last point, and whether A is positive or negative tells you whether to sort of start by going up or by going down. The type of question I find interesting is where you have a curve like this, sinusoidal curve, and you're given 2 points that are kind of representing the starting and ending points and creating the equation. And you can do this different ways. The order actually doesn't matter. Like, for instance, I could first decide, okay, this is a sine curve that's going up first, so I'll put a plus there. Then I notice that the amplitude is 2 because the height is the high point is 2 above the middle point. Now, the coefficient that goes before this parentheses, I'll look at what the period is. So it goes from minus 10 to 170. So the period is 180. So this B value, or the frequency, is 360 over 180, which equals 2. The fact that this is starting at negative 10 means I need to put a plus 10 there. And because the midline is here at plus 1, I put a plus 1 there. The truth is, you could do these 5 things, 1, 2, 3, 4, 5, in any order you want. Here's another one. I'll do them in a different order. The midline is here at 1. The amplitude is going to be 2. This is going down first, so I'm going to put a minus in front of there. If I'm starting on, we'll talk about cosine in a minute, but these are all sine so far. And now inside here, since I have 40 as the starting point, I want x minus 40. And because this goes from 40 to 160, that's 120. And then I divide 360 by that, and I get 3. So 3 goes out here. We could also do with cosine. Cosine starts at its high point and ends at its high point, and these 5 points seem to form a V. Be careful not to connect them like almost like a parabola. It kind of goes like that, and then like that, and then like that. So those are the 4 pieces of it. It's actually, you can see how if I connected this and I kept it going, it's like a sine curve that's shifted. So there's our cosine curve, and we can do the same thing like y. Something like this. I like to start with the minus 1, so I draw my sort of middle line is shifted. Then I use the 3 to tell me that sort of the top point's up here and the bottom one's going to be down here. So my cosine curve is going to go through there. And cosine, positive cosine starts at its high point and negative cosine starts at its low point. So because this is positive, we're going to start somewhere on that green line on the top. Where exactly? That's where the minus 30 comes in. We're going to go at 30 degrees to get that. That top point is 30, comma 2. If this were a minus here, I'd put it down on this bottom line at 30, negative 4. Now it's important to concentrate on this 4 here. That 4 means the frequency is 4, and 360 over 4 is 90, which means the ending point is 90 past 30, which is over here. It's real skinny at 120, comma 2. And now I could fill in a lot of stuff. Like I can go halfway between these 2 points and end up at 75, and it's going to be at the bottom there. And halfway between the 32 and this point down here is going to be a point on the middle line. And halfway between this bottom point, low point, and the next high point. So this is going to be squeezed in. It's going to be a real skinny thing there. If I drew more of them, they would end up being four curves fitting in a 360-degree space, so it's real skinny. Here's an example where, because the curves like this are called sinusoidal, whether they're sines or cosines. But if I tell you, like, here's a named point and here's a named point, and they're both maximums, or and I'm telling you to call this thing the starting point, then I'm asking you, even though this could be called a shifted sine curve, I want you to think of it as a cosine curve. Now, the middle line is over here. It's halfway between -5 and 1. So it's at -2. So I'll just put the -2 out there. And the amplitude is 1, 2, 3. And cosine curve usually starts at its high point. So because this is starting at its low point, I'm going to put a minus there. I'm almost done. The frequency, sorry, the period is 360, and 360 over 360 equals 1, so I can just put a 1 or nothing out there. And finally, the starting point is shifted over 60 to the right, so I put -60. And that's how you can identify the equation of a cosine curve.